Hello and welcome back to our series exploring the Automated Drone Image Analysis Tool, or ADIAT. My name is Charlie Grove. I'm the Director of Technology for Texas Search and Rescue and the creator of ADIAT. This video, we're going to do a deep dive into the general interface of ADIAT. So we're going to look at that kind of end-to-end process of what it takes to get some images and run them through the various algorithms and look at the results. We're not going to dive deep into the actual algorithms just yet, but we'll get a sense of where they play into this. Now, before we go into the interface itself, the best place to start is at the Texar website, which is where you can download it.
That Texar website can be found at www.texar.org. If you are in the state of Texas and looking for a search and rescue team to join, highly recommend taking a look around while you're here. You can learn about the capabilities of our organization and the areas we serve. Likewise, if you work for an agency in the state of Texas and you're looking for a search and rescue partner, by all means, I encourage you to take a look around at the rest of the Texar website. But for our purposes, what we're interested in is how to get to the ADIAT page from here. And if you're on the texar.org homepage, you can click on the About menu here and you'll see an option for Automated Drone Image Analysis Tool. Clicking on that will take us to the ADIAT page, where it has now been updated for version 1.3, which you see was just launched. There's a lot of great information on this page as well. Some of it talking about the product overview and whatnot that we reviewed in the previous video, as well as links to the actual downloads for the Windows and Mac versions of version 1.3, as well as an offline user guide that's a PDF that you can take with you into the field should you not have internet connectivity. You also see there's an interface guide walkthrough talking about the various components that we're about to review in this video, some information about the various algorithms that we have in place, both RGB and thermal, additional information about advanced features, and then some of the technical information, licensing information, and release notes all can be found on this one page on the texar.org website. Give you a moment. If you haven't already, please feel free to go ahead and download install ADIAT, and in our next clip we will jump right into the interface. Once you get ADIAT installed and open it for the first time, you should be greeted by a screen that looks like this. This is what we call the main window for ADIAT, and this is where we provide all the configurations before we run the algorithm, as well as our buttons to start, cancel, and view the results of the actual analysis once it has been completed. Starting at the top here, we have our input and output folders. So as mentioned in the first video, this is to do bulk processing of images. The expectation is the UAV goes up, takes hundreds of photos, it comes back down. I want to put all those images in one folder. So you can go to my demo folder here. I'm going to do RGB, select our input folder, and say, awesome, that's my folder. Let's go ahead and use that for our input images. I then select an output folder, which is where we are going to put augmented photos that have areas of interest in them. So the way this works, ADIAT goes through each individual image. If it finds areas of interest based on the configurations you have for the algorithm specific toggles here, as well as the overall settings, it will flag it as an image with areas of interest, and it will save an augmented version of that image. And we'll talk in a second about how we augmented that. But those are our two folders, our input and output folder. If I do have my folders open, I will note very quickly on the input side, ADIAT is set up to handle any sort of nesting you have. So if our main input folder has a subfolder in it called test, and test has a folder in that called test sub, that hierarchy will be maintained in the output folders as well. We're not going to flatten that or do anything like that. So you don't have to worry about files being moved around or anything like that. We will also not destroy the input images. They will be left as is. We're read only for our purposes when we're analyzing those images. Below our input and output folders, we have our three platform level configuration variables here. First one being min object area. So this is the minimum area that an object must be for it to be flagged as an area of interest. The reason we don't go down to a single pixel is because we'll get a ton of false positives, and that will just have 1 or 2 pixels that happen to meet the criteria for the algorithm. And with that, it would get flagged as an area of interest, and it's just more noise that you have to comb through in your analysis. Now, we also don't want to set it too large because then we start missing out on pertinent information in actual areas of interest. You might be thinking 10 seems fairly small, especially thinking back to the previous video where we talked about ground sampling distance and hey, I expect this person or a person to be somewhere in the 100, 200, 300 pixel range. But we have to remember not every pixel in that subject is going to meet our algorithm threshold. And if it's not a continuous shape, then it's going to be counted as a separate area. So best to leave the min object area fairly small unless you are seeing a significant number of false positives. Object identifier color. So this comes into play once an object or once an area of interest is identified. What we do in the augmented photos in the output folder is put a literal circle around the area of interest. What we're calling out here is what color do we want to use for doing that object identification? What color do we want that circle to be? Max processes is where we get into the capabilities of your computer, and it's literally how many images do we want to analyze in parallel at the same time. The more processes you have, the more resources it's going to consume in the computer, so just beware. And the best way, honestly, to figure out where that sweet spot is for your setup is a little bit of trial and error. Try it at 10, try it at 12. If it's bogging down the system, if the results aren't coming back very fast, you can drop it down. If it seems like the computer is just flying through it and has more to offer you, by all means, increase the max processes. Next, we have k-means clustering and normalized histograms. These are our two advanced features. I'm not going to touch on those yet because we will talk about them in a future video. Below that is our algorithm selector. So if we click on that dropdown, we see our 3 RGB algorithms we have in place, as well as our 2 new thermal algorithms that were added in version 1.3. Apologies for Mac users, those thermal algorithms are not available to you, so you should just see the 3 RGB algorithms. I'm going to go ahead and leave that on color range for now. Again, this video is just more about a general interface walkthrough, so I won't get into the specifics of what I'm choosing here as far as algorithm specific parameters, other than to note everything in this box is algorithm specific. So if I change it from color range to match filter, you see the variables in here or the parameters in here change, and I can set those for each of our algorithms. So going back to color range, I'm going to go ahead and set this up for with values I know will yield the results we're looking for. And that is it for our basic setup. That is all we need to do. We're going to run a color range algorithm. We picked our color blue. We set our ranges, and we can go ahead and hit start. And you'll see down here in the information window, it's going to start processing those 158 images. And you'll see it's saying, hey, nothing here, nothing here. And some of them, if you're reading very fast, can see it says areas of interest identified. Once it completes, you'll see image processing completed. In this case, 26 images with areas of interest identified. Total processing time was 11 seconds, give or take. And total images processed was 158. And for this setup with color range, it really is that fast. We see certainly usually above 10 images per second being processed. Once the processing has been complete, we can move over to the viewer experience. So we can click on the View Results button, and that will bring up our second window in ADIAT, which is the viewer. So from here, I'm going to go ahead and maximize that. We have our main window here. We can see in this particular image, here's the area of interest that was identified. And again, there's that green circle, which we said was the color we prefer to use for our object identification. We can also see over here on the right some thumbnails. So if you're going through a lot of these images, it's nice sometimes to just look at the thumbnails and not have to search through the whole image to figure out where that area of interest is. You can go over to the thumbnail, click on the thumbnail, and it will zoom right into that area of interest. You can then back it out using the mouse wheel or whatever other mechanism to zoom back out. There's a couple other keyboard shortcuts and things we can talk about. So if we double left click with the mouse, it'll zoom all the way back out. If we down click on the left button and go ahead and draw an area, that will zoom back in for us. If we right mouse button click and move around, it'll pan through the image. So looking at the rest of what we see here, we have the image name up here. We have how many images are in this set. These are the images with areas of interest that are identified. If there are multiple areas of interest, they'll be listed here, and we'll see those multiple thumbnails. Down here at the bottom left, we see the GPS coordinates. Again, those are the GPS coordinates of the UAV when it took the image. So it's not going to be the actual coordinates of the area of interest. It's going to be the coordinates of the UAV. Since this is gimbal down 90%, we're talking wherever dead center in the image is. We have some navigation buttons here to go to the previous or next image, or if you have looked at this image set before, want to jump to a specific image, we can go ahead and put that image number in here and go straight to it. Last item we have on here is the ability to generate a KML file. And what that will do, if we click on that, and let's go back up here and say, call that demo output. Minimize this for a moment. And I go back to where I just saved that KML file and open that. That'll open for me in Google Earth, for you, whatever GIS tool you have set up to handle KML files. And what you'll see is pins on a map for each of those images, the GPS location for each of those images that had areas of interest. So quick way to dump all that information about the locations where images with areas of interest were in that set of images. Jumping back over to ADIAT, we can go to the next image. By the way, there's also keyboard shortcuts for going previous and next. If you just use the left and right arrows on the keyboard, it's usually faster than moving the mouse and hitting the next image button. But we can look through these and we can see it's consistently finding that same shirt. And in this one, we found two different blue shirts. We'll talk about the color range algorithm in a little bit and why it would find it in one image and not the others. But for our purposes, just looking at the general interface, this just shows us, hey, we got both of those in here and we can click on each of them individually and jump straight to it. And yeah, pretty consistently, we're finding one or both of those blue shirts, depending on uh, what where we are, where the camera is when the images were taken. Back in the main window, let's go back up here to the top left where we have our menu, and you see there are three menu options on here. The first is load file. We'll take a look at that in a second. The second, though, is preferences, and this is application level preferences. The first being what theme do we want to use? We have a dark theme and a light theme, and I usually leave mine set on dark just to reduce eye strain as we're looking through tons of images. The second we see on here is called max areas of interest. And what that is a threshold. At some point when you're using ADIAT, you will come across a scenario where you set the parameters a certain way, you think you have everything right, and you hit go, and it's going to go through the first couple images and find just tons and tons and tons of areas of interest. And this is something of a safeguard. It's a threshold for where if the number of areas of interest in a single image exceed whatever that number is, it's going to pop up a little message saying, hey, do you want to continue? We've got like 200 areas of interest in this one image, and they're probably false positive, so some of them may need to be tweaked in the settings before we go through all these images. So just know that's there and that it's configurable. Area of interest circle radius. So this plays in with the min object area. So with the area of interest circle radius, what we're saying is we have the area of the object, whatever it is. In our case, we know it's going to be bigger than 10 pixels. And we could just draw an immediate circle around that, the smallest possible circle. We want to create a little bit of a buffer there. So rather than just the smallest possible circle to enclose our area of interest, we're going to go out 25 pixels from there. And what the tool is going to do behind the scenes is if you have two areas of interest and now they're overlapping because those circles overlap, it'll deduplicate that for you and create one larger circle around what was two separate areas of interest. Again, trying to reduce the noise, trying to reduce the number of things you have to look through. We simplify it and deduplicate that as much as possible so that you only see unique areas of interest. Finally, two other configurable items. The coordinate system, we support UTM, lat long, in both decimal degrees and degrees minutes seconds. That comes into play for the GPS coordinates that are shown on the viewer, and the temperature unit, which, as you would imagine, comes into play for our thermal algorithms. So we talked about preferences. The first menu item on the list is actually load file, and this gives me an opportunity to talk a little bit about the output results and how that looks on your file system. So if we go into our folder where we had our input and output directories, you'll see inside that output directory, we created a new subdirectory called ADIAT results. And in that, we see the augmented output files. And by augmented, I mean if we open one of these, we see that it is exactly what we had in the viewer. So it is the same image as the initial image in the input, but with the areas of interest circled. This is important because if you choose not to use the ADIAT viewer, you are by no means beholden to do so. You can use any image viewer you like and look at the images there. But we also have this XML file, and what this XML file holds is all the information, not only about the results, but about the initial configuration. So I'm going to go back here and I'm going to change this to match filtered and 10 processes and 8. So it's all different than what we started with. Now if I go to menu, load file, and then click on that XML file and open it, you see it sets it back to what we had when we executed our analysis. We also see the view results button. We can click into that and go right into the viewer. This is important because if you're doing thousands of images, you definitely don't want to have to rerun the analysis every time. You want to just go back to the viewer. So all you have to do is go to menu, load file, find that ADIAT data XML file, open that, and that will get you right back to where you were when you ran the analysis the first time. If we go back up to the menu, the third option we have on here is our new video parser that was introduced with version 1.3. Clicking on that will open this dialog where we can select a video file, SRT file, and output folder. Video file, hopefully fairly self-explanatory. That is the usually MP4 or whatever is captured by the drone. The SRT file, if you're not familiar with the concept, if we go over to a normal video player, the Windows Media Player, when we watch the video, we just see the videos you expect. We also have the option of enabling captions or subtitles and choosing a subtitle file. Now, that subtitle file is usually an SRT file, or at least that's what DJI uses for their videos. And rather than true subtitles, what DJI stores in there is real-time metadata about the drone and the cameras and everything else going on. So now if I hit play, we see all this information about the time change, frame counts, but most importantly to us, the latitude and longitude, which is the real-time location of the drone when that particular frame was captured. If that information is provided to us through the SRT file in our video parser, we are able to leverage that to go ahead and geo-stamp the images that are outputted so that we can present that information to you in the viewer. So going back here, we selected our video file, we'll select our SRT file, and we can go ahead and select our output folder. So what's going to happen, and you see the last parameter here is the time interval in seconds. So what's going to happen is as the video progresses, every 5 seconds in our case, it is going to take a still frame image and put that into that output folder. Again, if the SRT information is available and provided, we will imprint the GPS location into the metadata of that image so that we can use it for further analysis. To run this, once we have these parameters set, we go ahead and click Start. In this case, the video is 47 seconds long, 10 images will be captured, and as it goes through its process, it'll keep you updated on the progress here. In this case, there were only 10 images to be captured, so it only told us once, and says, hey, we're all good, images have been created. If I go to that video output folder, we will now see those 10 still frame images that it captured. Now, I'm sure the question is going to come, why don't we just use video? Why do we set the default as still images? As good as the video cameras are on drones these days, they're still nowhere near the resolution of the still frame camera. So a still frame image from even consumer level DJI drone is probably somewhere around 20 megapixels, whereas the resolution of a 4K video single frame is 8.3 megapixels. So there's a lot being left on the table if we choose to parse a video instead of using the still frame images. That being said, if that is what you have, absolutely it is better than nothing, and we are happy to support it. We are happy to have that capability in the tool, and it is there for you to utilize. Having completed our demo of the video parser, I believe we've completed the general walkthrough of the user interface for ADIAT. A few tips and tricks though before we sign off for this video. So as a general rule, if you're doing any sort of large image set analysis, and I'm talking thousands or tens of thousands of images, it's a good idea to start with a small test set. So I'm looking at 10, 20, even 100 images where you can try to get some of these parameters set up ahead of time because it'll save you a lot of heartache. There's nothing worse than setting what you think are the correct parameters, hitting go, waiting for it to churn through all 10,000 plus images only to find out, oh, if I just set this to 50 instead of 75, or if I choose a slightly different color or a slightly different minimum object area, I would have seen much better results. So if at all possible, start small. Likewise, as I mentioned, minimum object area, keep that number way smaller than you think it should be. I rarely go above 10 on that. And finally, the max processes, we talked about this too. The best way to figure out what works for your system with your current algorithm and configuration is to just to test it. So if I run this, it's going to take about 11.5 seconds again, and varies depending on how many times I run it and if I'm recording video at the same time. So we're at 11.25 seconds. If I bump this up to 12, run it again, we see, oh, okay, we're up to 12.56 seconds, which isn't a huge deal when you're looking at only 158 images, but if you get into the thousands of images, those extra seconds add up. So again, it's all dependent on your system. It's dependent on what else is running on your system at the same time. Don't be afraid to change that setting, especially if you're doing a test set first to get it tuned in for your current circumstances. For now, that is all we have to share. We look forward to seeing you in our next video where we will be talking about our RGB algorithms. Thank you very much. Bye.